Okay, welcome to the Transforming Assessment webinar. This is the session for 1st of April 2020. We'll be looking at personalized tasks and anonymous peer grading by Mathias from Germany. Sorry, I can't pronounce the name of your university, but thank you very much, Mathias, for coming along.
Yeah, good morning to everyone. Actually, the university is pronounced Otto von Guericke. He was a major of our city, and he was also a physicist who found about vacuum. Did some very famous experiments, at least in Germany, with vacuum. And to be honest, my first name is also pronounced Mathias. We don't have this TH in Germany, but anyhow, this is I'm used to it. Okay, so the topic that I'm trying to explain, and by the way, I will switch off my video now because everyone has seen me, and this will hopefully save some bandwidth for us all. Yeah, as already said, personalized task and anonymous peer grading. So the plan is that I explain a little bit what is the motivation behind this, why I have developed this feature or this method, and then I will show some typical tasks. They are from our course about fundamentals of electrical engineering. So if you are familiar with electrical engineering, you will maybe understand these tasks. Otherwise, it's just to give you a brief idea how these tasks look like. Then I will explain how the procedure works, and I will show some results, and we can maybe have a little discussion about this. So why all this? What is the motivation behind? And before I start to explain this, I would have to like a short survey and ask you, what is your background? So are you, let's say, from general education, from school or high school, or are you from a university or college, and then social sciences, economics, natural sciences, technology, or do you really come from electrical engineering? Just post maybe the number. We have tried earlier. The survey tool in this Blackboard is not so nice. That's why we just said it would be easier to do this just via the chat. Okay, so I have some 3s and 4s, and I think lots of universities, but not necessarily engineering sciences, and also yeah, like I think some learning centers and teaching units that support other structures in your university. Okay, thanks for this. So not too many electrical engineers, I see. Okay, so I will try to not to go into too much detail about the electrical engineering stuff. Thank you. Okay, so the motivation is that, as said, we have a course about fundamentals of electrical engineering. It goes over 2 semesters, and of course, at the end, over these 2 semesters or over 1 year, we have some exam. And the classical exam looks like this, that of course we force the students to solve tasks alone without any support of books or of formularies. So they cannot use their they cannot use their smartphones, they cannot use their computers, they can just use their calculator, and they can also not discuss with each other, because of course we are interested in what they can do on their own. Still, I think the problem is that I'm a little bit confused about the chat. Okay, the problem is that no engineering problem like this, or no real world engineering problem is solved like this. I mean, no big companies. The boss says, "Here, go to some room, be there alone for 3 hours just with your calculator and a sheet of paper and a pen, and now develop the new charging system for the electric vehicle." Yeah? This won't work out. So yeah, of course, universities are somehow traditional and stick to this classical performance assessment, but yeah, it's no real replication of the real world. And then, of course, it does a lot of work for the lecturers to grade all these papers. So, as said, the demands in the real working world is that we have something like the internet. Students can use computers. There are lots of simulation tools for all engineering sciences, also for electrical engineering. And persons can also discuss with each other and can solve problems and collaboration. And I think this is nothing that we really assess now, at least in Germany, in our classical exams. Maybe it's a bit different in Australia or somewhere around the world, but at least in Germany, we are very, very traditional about this. And so then we also have something like e-learning tasks. So where we can have something like formative assessment during the course. And yeah, so I've inserted here some classical or some typical tasks from our Moodle, from our e-learning course. I've not translated it into English, but there's a schematic and there are some values for these elements, and then the students should calculate a current or a certain voltage in the schematic. And the real task for the student at the end is just to fill in, and I mean, of course, this is interesting, but at the end, what the student has to do is fill in a number here, the right number with the right unit, click some button and check if it's right or wrong. And what typically happens, at least what we have found out, is that only these students do these tasks that would not really have to, because they are already good, and the students that have the greatest potential for improvement, let's say it like this, they at least on a voluntary basis, they do not do these tasks. And then sometimes if they do them, it's done in a way that they send some good student and say, solve this task, give me the number, and at the end they just fill in this number and say, hey, I've somehow solved this task. At least if you give them points for this. So yeah, it's somehow nice, of course, because it scales. You can give such tasks to a lot of students, and the learning management system like Moodle will automatically grade them. Yeah, but in my opinion, it's still not really a good task to check if people have really understood about what they are doing. Okay, and there is a lot of mental effort, let's say, in really developing a free handwritten solution. Yeah, start with a white sheet of paper and write down formulas for a problem. Think about what would be a good approach. What formula do I need? How do I insert all the values that are known into these formulas? How do I rearrange these formulas to develop some solution for the engineering problem, for the physical problem? Take care about the units, take care about the calculus, and so on and so on. And what can also be done in such free handwritten solutions, of course, is that students can draw diagrams, they can draw plots, they can draw schematics, they can use schematics they are already there, and draw arrows in schematics for there's a voltage in this direction, there's a current flowing through this and this element, or there are elements in some flow chart connected to each other, and so on and so on. And this is some solutions like this are very difficult to develop in the classical e-learning systems like Moodle, I think. I mean, you can have multiple choice questions and you can have like some drop-down questions, but it's really difficult to really test these kind of free handwritten solutions. So our idea was that students get tasks that they solve by hand on a piece of paper, because this is a little bit how our exam works, and where you really have to think about the problem if you want to start with a blank sheet of paper and write down everything by yourself from scratch. And then students should be able to grade each other or to review each other, even if they were not able to find a good solution for their own problems. So they must be really good solutions for these tasks so that students can grade each other, even if they did not really understood about their own problem. And the tasks like this, or the solutions like this, they should be personalized so that the students can talk to each other about their problems and can discuss their problems, but they cannot just copy from each other, or they cannot plagiarize. This was the idea. And yeah, I will show later on the procedure, show some how some typical tasks look like. And I have developed since now, I think, 11 or 12 of these tasks. And because this is a typical question, it takes me about like a weekend or so to develop and to program such a task. So how do these tasks look like? And here I have translated it into English. Again, if you're not from electric engineering, you might not be able, let's say, to find a solution for this task, but typically the students get all the very same task. Like there's a displayed curve of a current, and from this current, the charge should be calculated, or the charge is searched for. And there are some time sections and some initial charges given. And so all students have exactly the same task, but every student gets a different diagram. And these diagrams are generated by the matriculation number. Every student in Germany has a 6-digit number at our university. And with this 6-digit number, I feed some random number generator. So every other matriculation number gives a different diagram. So another number gives a different diagram that, for example, looks like this. But if I insert the same number in this random number generator, I get the same diagram again. So I can regenerate these tasks in case of something fails, or if in case of something is wrong, and I just have to redo it. And so again, a different number gives a different diagram. And now you can already see a little bit how it works. In this first section here, it's always a linear function that goes through the origin. And then in this second and third and fourth section is always a constant. So the effort in calculating this for every student is the same, but at least they all have a different diagram and they all have different numbers. So everyone has to think about his problem himself. They can discuss each other and they can try to find a solution together, but at the end, everyone has to find his own solution. Even if they are quite similar, they are still different in the numbers. Okay, and as said, the good thing is, because the students have to review each other and they have to grade each other, and they should be able to do it even if they were not able to find the proper or the correct or the right solution for their own task, I can generate very detailed sample solutions for all these tasks. So again, this is based on the matriculation number, and for this number, I get this solution. So what really changes here are just, in this case, really just these numbers. This is a quite simple example, are just the numbers inside these equations here. So for this diagram, there is a 1 there, and then we integrate over this 1, and at the end we get a 0.5 here, and so on and so on. So, but everything is step by step written down very detailedly, and so this is just for the first of these 4 time sections, and so then for the next student, the solution would look like this. So there's, in this case, really just a different number here and everywhere. And so for every student, as said, I can generate without problems. The computer algorithm, the program does it automatically. I can generate all these sample solutions. And if you ask how it's done, it's based on LaTeX, and what's done in LaTeX, or what can be done in LaTeX is as these diagrams before. I can also draw the diagrams automatically. How would the final solution for the charge? Now we started with the current as the function of the time, and what was searched for is the charge. The charge as a function of the time. And so for every student, again, based on this matriculation number, we get a different diagram how the charge develops over time. And now you can see that even if the task is the same for everyone and just the diagram that we start with is different, of course, at the end, we also end up with a very different diagram for every student. So this should give you some basic idea on how such a typical task looks like. And this brings me to a second survey. And the question is, can you think of some kind of the same way personalized or randomized tasks that could be also used in your branch, in your field of science, in your department? And again, I would ask you just to paste the number into the chat box, and I see some 3s and some 2s and some 1s, and that's good because it means yes, it's possible. Yeah, and I know a colleague from our university in Magdeburg who has developed similar tasks for fluid dynamics, so for another branch of engineering sciences. Okay, thank you. So then I want to show a second task. It's numbered 7 here because it was the 7th task that I have developed, and I have a larger set of slides where the tasks are numbered like this, and I would not confuse myself. That's why it's maybe confusing for you, but for me it's task number 7. And yeah, again, the task is the same for all. Here the idea was that the students should draw such a phasor diagram. And if you don't know what a phasor diagram is, don't mind, but the idea is that they draw such kind of a diagram, and from this diagram at the end it's really difficult to see if it's right or wrong if you see just the complete diagram, and if it's wrong it's very difficult to say until which stage it is right and when it gets wrong. So here the students should not just write down their solution and upload a photograph or a scan of it. Here the idea was they should create a video of how they draw this diagram. So I said, because they should not show the final result of this question or of this task, but they should show the process of how they created their solution. And I gave them some hint and say, if you have a good tablet, you can make a screencast of how you draw this with your pen on the tablet, or you can create a simple tripod for your smartphone camera and just film your hand while you draw this on a piece of paper, and give them some hints on what they should look at and so on. And said also there should be no sound in the video because it should be anonymous. Yeah, everyone has a certain voice. We do not want to hear this voice. Do not take too high quality videos because otherwise it would be too large. It should also not be longer than 10 minutes and 500 megabytes, 10 minutes, because someone has to watch these videos and review it. It should not take too long. And 500 megabytes was somehow the upload limit of our e-learning Moodle system. And then just, yeah, when drawing, they should use different colors because it's easier to then see what line belongs to which phasor in this diagram, and they should look at the scale and so on. And this is the idea that I gave them on how to build such improvised tripod for filming the handwriting. very easy to build from household materials. And to give them some brief idea, I also created some example video and uploaded this to our e-learning system and to our Twitter account, where I would solve a task like this. And I think it took me something like 5 minutes. And then I said, okay, if I can do it in 5 minutes, 10 minutes should be enough for the students. And so again, then everyone got this very same task, but each student, again, based on the matriculation number, based on the random number generator, got a different schematic. So one schematic looks like this, and another schematic looks like this, and another schematic looks like this. And now you already get the idea that it's always 5 elements. For example, here 2 resistors and some inductor and some capacitor and another resistor. And so every circuit has 5 elements, and there are always 2 changes of the topology. So we have a series circuit here, then we have some parallel circuit here, and then again we have some series connection of these whole branches. And so these 5 elements and 3 changes of this topology we have in every one of these circuits. So the effort in drawing these phasor diagrams at the end is the same for all students. Even if these schematics all look very different. And again, students can discuss these problems with each other. They can also look in the internet, but they will not find exactly the same circuit. So they have to think about a solution for themselves. And so the sample solutions, and here this final phasor diagram then looks, for example, like this and like this, or like this, or like this. And you can see it's always 9 phases that are inside this phasor diagram. But each phasor diagram looks very, very unique because every circuit is unique and every circuit has also different values for the elements. So that's the idea behind this task. And as said, so by now I have 11 or 12 different tasks like this. Okay, so then I want to briefly explain how the procedure works. So what happens technically in the background. And this was also the schematic that was used to advertise this webinar. And now I've translated it also into English. So the students here on top, these are always the students. The students register in our e-learning system, and in our case, the e-learning system is a Moodle. And I download a list of students from this Moodle system and feed it into MATLAB. I've programmed everything in MATLAB. Why MATLAB? Okay, I'm an engineer, I'm an electric engineer. Electric engineers know how to program in MATLAB. I know that, it's not so well known in other fields of science. And my colleague in Magdeburg, Olivier, who did this for fluid dynamics, he did all this stuff in Python, for example. But at the end, it's just a programming tool. It would be good at the end if one could do all the programming again back in Moodle, but it was much easier and much faster for me to program everything in MATLAB than in Moodle. That's why I did it in MATLAB. Okay, and so from MATLAB, I use the matriculation number, and with the matriculation number, I feed some LaTeX source, and the LaTeX source then generates all these tasks, and for every task I get back some PDF file, and this PDF file is sent via email to the students, and the students then have some time to think about their solution. And at the same time, I also generate these sample solutions and just store them intermediately into some folder. And we need this folder later on to assess these sample solutions. Okay, so then the next step is that the students, usually they have 1 week to find a solution. The deadline for submission is always on Monday at 10 p.m. in the evening. and they upload their solution with task form into the Moodle system. And so then I download all the submissions from all the students at once using a zip file, and again put this into my MATLAB algorithm. And what the MATLAB algorithm does is it now mixes up these tasks and sends every student 2 emails, and the emails always say, okay, here is one solution of another student and the corresponding sample solution. Please grade this and upload it back into the Moodle system. And the second email says, okay, here's the second solution from another student, the second corresponding sample solution. Again, please grade this and upload it back into our Moodle system. So then the students think about how to review these papers, and they say, okay, this is right or this is wrong, based on comparing the solutions with the sample solutions. So again, they usually have 1 week to do this. And again, the deadline then is Monday evening, 10 p.m. And what they upload back then in the Moodle system is the reviewed or the graded tasks of their peers, and they insert the point number, the score that the students have, their fellow students have reached into a text field, again back into our Moodle system. And yeah, these points here, they are unfortunately, they are necessary, otherwise no one will really solve these tasks. And we don't give these points, so the points are necessary, at least from our point of view, as some extrinsic motivation. Unfortunately, it is like this. And if something is wrong with the points, then the students write long emails. Oh, my fellow student has forgotten that this is right, but he said it's wrong, and I think it's right, and it is really right. And can I get this point? And so, and then we always say, ooh, it's not really important. It's not about the points. It's about that you have thought about this problem, and that you have developed some method on how to solve this task, and that you learn something, and it's not really about these points, but the students are really upset if they don't get their proper points. Okay, so then I have all these graded solutions in Moodle. Again, I download them all as a zip file, put them into my MATLAB algorithm, and the MATLAB algorithm then automatically sends back each student his 2 reviews and the corresponding sample solutions, so that then the students can have a look at, was I graded correctly? Does this correspond to the sample solution? Was everything right? Was everything wrong? And so on and so on. And these points, they are stored in some score list, and the score list is not really used for the exam, but the students have to reach a certain score to be allowed to take the exam. So it's like a pre-exam or something. I don't know how you would like to call this, but the points are not really used for the final exam, just to be able to register for it. Okay, so to discuss the results, what has happened, and so a typical cycle looks like this, that I sent these tasks to about 200 students. This is roughly the number of students in our course. And yeah, usually something like 150 students would take part and would upload a solution. And so the other students are not interested, or they forgot about it, or maybe sometimes I think they also already have enough points, and then they say, okay, I'm fine, I can do the exam, I do not need further exercise anymore. And then I usually lose some 5 to 10% of students for the review. So yeah, typically, let's say 10 less upload reviews. then of course some reviews are missing, but still, I mean, for every student for every task, I get 2 reviews. So if one of them is missing, this is not really a big deal. And the students are told that they only get points for their own solution if they also upload the reviews. So if they forget or if they are not interested in reviewing each other, then they also do not get points for their own solution. And as I said, they are very, very interested in these points. So they the percentage here is usually quite high. So I would say this is, yeah, compared to other tasks that we give out to students and to these e-learning tasks and so on, it's some excellent activation of the students. We also reach the students that would usually, typically on a voluntary basis, would not do these tasks and would not develop a solution. And I think it's also good preparation for the exam without this teaching to the test that you give the students exactly the same tasks for exercising than the same tasks that would be asked for in the exam. And typical distribution of the points, we always, for each task, we give 16 points so that these tasks are comparable with each other. And a typical distribution of the points look like this, that really most of the students would get full points or almost to full points. And yeah, I think this is also okay because they have 1 week. As said, they can ask each other, they can discuss with each other, they can ask the internet, they can, I mean, at the end, they have to write down a handwritten solution, but they can also do a simulation, they can also do some calculation in MATLAB. They have a lot of time to check their result. So I think that's why it's quite common that most of the students get full points. And the difference between the reviewers, between the 2 scores is usually also quite small, just 0 or 1 point. And yeah, I mean, still there are quite a high number where, let's say, one reviewer just gave 7 points and the other one gave 13 out of 16. And then my algorithm gives me a warning and says, oh, look, there's a huge difference between reviewer 1 and 2. Maybe someone should have a look that really has knowledge about this topic. And then I or some colleague looks about these solutions. And then, yeah, these are sometimes really difficult solutions. So the idea of the student was good, but then still how it was done was really bad. And then it's always a question if, do you count points or do you count mistakes, and how you do it, you will end up with a different number. Then what's also quite interesting, because my Moodle system tells me at which time the students upload these tasks. Of course, I do not really know at which time of the day they do their tasks, but I assume that if you have done the task, you will not wait for 3 hours and upload it then, but if you have done the task, you will submit it. So here, out of something like 2,400 submits, I have made a histogram of at which time of the day the students are active and upload their tasks. And as you, I mean, this is over the whole week. Our deadline is Monday at 22 p.m. So here's the deadline. That's why, of course, a lot of this happens before the deadline and much less after this. But students are quite active during the night, and here early in the morning between 5 and 6 or 7, you can shut down all servers and install updates on your Moodle system. No one will care about this. So one interesting question for me, and a lot of things happen in the chat already. To be honest, I cannot speak in English and at the same time look and read the questions in the chat. I will hopefully come back to this later. So the survey now would be, what questions would come to your mind regarding this evaluation? Yeah, so I have lots of data from the students. Let's say at which time they submitted, with which point score, and so on and so on. And as said, I'm an engineer, I'm not a didact. From from a pedagogical point of view, what would be interesting questions to do with this evaluation? Oh, thanks. Okay, there's, I think this was just a comment about blind peer review. Yeah, so for example, what would be an interesting idea for me? Maybe I will do this in this starting summer semester or in this starting summer term, that when the students upload their results, that I also ask them, how difficult was the task for you? How would you grade the difficulty of the task? Because I've not shown this curve, but what is also quite interesting is if you look at the curve, how the students, maybe I can draw this here. So if this is the time, the 1 week that they have, and if the deadline is here, then of course what happens, the students have the full week, nothing happens, no one uploads it, no one uploads, and something happens, and most of the uploads are really, really shortly before the deadline. And what I've seen, interestingly, is that if the tasks, for me, if I would say it's an easier task, then the curve is flatter, and if it's a more difficult task, then the curve is really, really steep at the end. So from my point of view, this would be something interesting to discuss. Interestingly, what happens if the students review each other and they have 1 week to upload the reviews? It's more or less always a linear curve. So if you develop a solution, you ask really for the latest moment to do it and to upload it. And then if you are asked to review each other, the students would, I think, at the moment where they get the email and read this email, they would directly do it and upload it. And that's why it's more linear over the week. And yeah, I have no real idea about this, but some students told me that is, if you review each other, of course, you also get some idea if your own solution is right or wrong, and this is what you want to know at the end. Okay, some fun facts. I could not translate this because these are screenshots. Here, a student has uploaded his solution under the file name, let's say, full score or full points.pdf. I think that's very interesting. Another student has uploaded his solution under the file name my solution or my own solution, which is also kind of funny, I think, because if there's a file which is called my own solution, is there also a file that's called not my own solution? I don't know. And here someone has called his file name for submittance submitme.pdf. Yeah, and then what we also see is that students have problems in operating their computers. So here, a student uploaded the file link and was not aware that this, of course, will not work, and was also not that the file link, of course, is just, let's say, 500 bytes or something like this. And then I wrote him an email and said, look, you have just uploaded a link to the file. The link would not work on my computer. And then he said, no, but it works on my computer. And I said, yes, of course, because you have the file on your computer, but I don't have the file. It's just a link. So I think we also observe, I mean, these are first semester students, but I think we observe a lot of problems with that students do not really able to operate their computer, operate their smartphones, their laptops. Then another problem is poor image quality of submissions or corrections, yeah, so that they make a photograph of their solution, but there's some shadow on it, or there is some glare and you cannot really see what happens there, and that then people also do not really care about this. And there are very, very good smartphone apps, I think, where you can make a photograph and it will automatically correct the contrast and will also correct this misalignment here, so that you can always get a perfect picture. And yeah, we also suggest the students to use these apps, but yeah, sometimes still difficult. Another question is, of course, the credibility of the corrections. Again, I could not translate this because it's screenshots, but here there are spelling errors. And so if you think, okay, students are not able to write their sentence correctly, is also sometimes strange. And then there is some potential of improvement in our e-learning system, especially when the students insert these numbers for these points. And so the last question is, which e-learning system do you use at your college or university? Okay, and it looks like that most people would use Moodle, so okay, thanks a lot. And the last two slides are just questions that I would like to discuss with students on a roundtable discussion for further development, but to be honest, I've not found time to do this. And at the moment, of course, it's also quite difficult to do roundtable discussions with students. So thanks for your attention, and I would be happy to answer some questions. Matthew, have you collected questions in between from the chat?
They did go flying past. I did have a question that I had put in before was, have you used your random sort of question technique for giving students end of semester end term exams, or are these just sort of like formative learning activities?
They are just formative learning activities. So the exams at the end are really in this, I mean, maybe we will change it in the future, but at the moment they're really in this way that all the students get exactly the same tasks, so that it's really, really comparable. I mean, I think the problem is that I'm also not an expert in this, but that there are some legal issues in the background that exams should be comparable, at least for one batch of students, and that you could run into legal problems if you give different tasks to different students for the final exam.
Sure, yeah. I think there's probably ways of statistically working out if the questions have equivalence in terms of their difficulty. I'm not an expert in that area, but I believe there is probably some method to do so.
Okay, so there's a question from Peter who asks, do you use peerwise or similar? I think I've heard about peerwise. I've no idea at the moment what peerwise is. I think it's a tool to do peer reviews. No, I've not used it. I don't know it in detail.
I can tell you if you like.
Okay.
Peerwise is like a crowdsourcing tool so that students can create a whole bunch of multiple choice questions for you, and then the students then do and rate the questions. So the idea is, if you're able to teach somebody else or explain a concept to somebody else, then you yourself are learning a lot. So from a point of view of a student having to create a question themselves, then they are learning, and then they have to, explain it and include feedback for the wrong. Like if it's a multiple choice question, they have to include valid feedback for the wrong answers as well as the correct one. Yeah, it's quite increasingly common. I think quite a few universities in Australia use it. It's used all around the world, but definitely peer-wise, you can look it up. If you have Moodle, there's also a plugin. I think it's called Student Quiz. That's a similar idea of crowdsourcing. You're just using the standard question types in Moodle, and you get the students to create the questions, and then they can rank each other's questions, etc.
I've just pasted the link to another tool from the Technical University of Dresden in Germany that is also for peer assessment, and I think there's also a tool for peer assessment in the Moodle itself. But the problem there is that you can just give one task for all students, and you can also just give, let's say, one solution or one one joint grading form for all the students that is used for the peer review, and you cannot have this kind of personalized or randomized tasks that I do. Okay, so then there is a question from James: what is the best citation that describes this approach? At the moment, there are just German papers about this. My colleague Olivier from Fluid Dynamics and me, we have written an English paper that is submitted and reviewed. That should be published soon, but I don't have a proper citation for this at the moment. But there are some, yeah, if you write me an email, James, I can at least send you some German citations, and I can also send you a copy of this English paper if you like. Oh, very good. Okay, so are there more questions? Unfortunately, I cannot scroll the chat at the same time while people paste something in the chat. Are there more questions?
Yeah, folks. The chat is not brilliant, so folks, if you could just type your questions into the text chat again, if you happen to do them a lot earlier, and we can get to them.
Okay, there's a good question. What I'm interested in is the feedback the students actually self-generate if you ask them, not the teacher, to make comparisons of their own work with other submissions or their own work while comparing two others with each other. Yeah, so the students, as said, the students grade each other based on these also automatically generated sample solutions. Yeah, I think it would be possible to do it just comparing their own solution to other solutions, but it's engineering tasks. I mean, there is not so much to discuss. You can have different approaches for certain problems, but it's not, let's say, like writing an essay where it's not just right or wrong, but there's a lot of gray in between. I think it would be difficult if they just make comparisons or make a comparison of their own work with other submissions. But maybe what also answers this question is that the quality of the reviews is usually very, very good. So we have made very good experience also in other subjects with this peer review, that the students do it really, really fair and also really, really thoroughly. So I think they also have a very good feeling how much effort they put in their own solution. And if they look at a different solution, I think they, not by looking if it's technically right or wrong, but just in a way how it's written and in a way how it's presented, I think in most cases they also have a quite good idea or impression if the other student, their fellow student, has invested some effort in creating this solution and has thought about it, or if it's just drafted very, very quickly in 5 minutes and yeah, put very, very quickly on a piece of paper. Then there's another question. What is the likelihood of using peer grading in assessing essay tasks? We do this also. I've not presented this here, but we also do it. We have some seminar about scientific writing on scientific working, where students get a lecture about how to write a paper, how to give a presentation, how to draw a proper diagram, how to cite correctly, what is plagiarism, and so on, how it can be avoided. And then they should write a very short paper about a non-technical topic. So why is so much tomato juice drunken on airplanes? Why is Snow White? Has Coca-Cola invented Santa Claus? Some non-technical topics. That's why it's called non-technical project. And their students also grade their papers each other, and this also works very, very well. But you have to explain it to them. So we usually use one full lecture, 90 minutes, to explain on a sample paper how this review works and what they should look at, and how to fill out this review form. And if you explain it properly, then they also do it very, very well. Yeah, but it needs a strong rubric, exactly. You cannot say, okay, here's a paper, do some review, then everyone will do something else. You need to explain it very well, and then it works usually very, very good. And the students do it very fair. Yeah, yes, and for, as I said, for this essay, we do it and practice it. For this electrical engineering, we have too many students to do it really in the seminar, but we do it then in the lecture where we have all the students, and then we shortly show, okay, this is how some solution looks like, this is how the corresponding sample solution looks like, and then you go through it step by step and check. And please also be careful, check not only the numbers, also check the units, and what would be proper signs to mark if it's right or wrong. Okay, and there's a question, are there tips in supporting students to internalize the success criteria and to use the rubrics effectively for marking and feedback? To be honest, I do not really get the question.
I think personally it's about having students practice with it. I've seen it done really well in other STEM courses as well, where you have students evaluate each other against the criteria in classes, and then they discuss about the criteria. So then there becomes like a group understanding about what the criteria and what the standards each level mean. So I saw a tutor at University of Queensland. She did a very good job of this. Led the tutor training program along these lines, where they had the people that first they gave them the work. They asked them to say, oh, how much would you give this, a credit, a distinction, or whatever. They would put up their hands. They had a voting, and then they handed out the criteria sheet, the rubric, and they did the exercises again. And then after a discussion, they did the exercise for a third time. And what they found is by the time they got to the third time, the group had converged on the standards around and the standards and the criteria or measuring the standards of the criteria reasonably well. So I think it's just like you do with marking moderation between, you know, a class of tutors or a practical demonstrators.
Yeah.
You get them together and you do a sample work, and you mark it together and you discuss it. So I think it's the same. We do, if we're asking students to do peer reviews, I think we have to teach them how to do peer reviews. We have to teach them about the criteria and the standards, and we discuss it with them. So that's my 5 cents on it. Yes, calibration, exactly. Yes, Jackie, you're right.
Yeah, I think we do this at least for our class or for our lecture. We do it in the seminars, so we do not have just only the lecture with all students, but we have 7 or 8 or 9 smaller classes every week, where we just have a group of 15 or 20 students, and yeah, they also have some kind of peer teaching model. Would be too difficult to explain now, but I think we also do it not with this personalized peer review tasks, but in our usual seminars. Students write solutions on the blackboard, and then the solutions are discussed, and the solutions are corrected, and so on. So I think we do it, but in a different way. But yeah, these self-generated own criteria are in comparing them with other criteria, it definitely helps to calibrate these internal criteria. Thanks, David, for this comment.
Yeah, I also would have to say that this is an important skill for professional practice. I mean, they have to be able to judge their own, success in the workplace. So it's a good idea to do it now when the lives and money are not at risk, as it were.
Okay, are there further questions?
Mathias, I think we are just about at
Yes,
the end.
okay.
It is nearly 7 p.m. here in Sydney, so if there's any last-minute questions, folks, now's the time. If you would like to ask a question via your microphone in the last minute, please put up your hand, and you're welcome to do that as well. So, okay, thank you very much, folks.
You're welcome.
Yeah. Let me just, we do have a new session coming up that's just only been stuck on our website. If I can manage to find out what I did with that. Helps to be prepared for these things, doesn't it? Okay, so the session will be coming up on the 29th of April. It's about detecting and addressing contract cheating in online assessment. I think it's probably going to be a timely kind of a topic because at the moment everybody is changing their assessment modalities, they're changing their assessment mixes. The rush to online with COVID-19, etc., is forcing people to rethink about their assessment mix, and often that is being turning away from exams towards things like take-home assignments and that sort of thing. My feeling is that there'll be some concern in the academic community about the potential for the uptick in the contract cheating. So from that point of view, I'd like to present the session. It's going to be presented by Phil Dawson, who's a well-known person in Australia with work on academic integrity and contract cheating and things like that. So that will be 29th of April. Look out for the email shortly. You can sign up now at the Transforming Assessment website. So I'm going to stop it here. Thanks, Mathias. Excellent session. I'm sure many people, particularly in STEM disciplines, will find it very useful. So thank you very much.
Thank you.